Hey, so what'd you get for example 5 when you were evaluating this one-sided limit? Let's take a look. So the limit as x approaches infinity, pi, it's close enough, pi from the left, sine x over 1 minus cosine x. You just do a direct substitution, just like normal. It doesn't matter that it's pi from the left, pi from the right, or just pi. You take sine of pi, since it's continuous, over 1 minus cosine of pi, since it's also continuous, and it should be equal to the value of the limit. But, it's entirely possible that this function by itself is not continuous. Anyway, so what's the sine of pi? Well, I probably want a unit circle in here. What a lovely circle that was. Okay, and then we're talking about pi, which has the coordinate -1, 0. So the sine is 0 and the cosine's -1. So I have a 0 on the top. Oh, so far so good. And then on the bottom I have 1 minus a -1 plus 1, which is 0 over 2, which is just equal to 0. Look at that, no L'Hopital's rule. I'm wondering how many of you were fooled into using L'Hopital's rule. Remember, we can only use it if you have the indeterminate form, 0 over 0, or infinity over infinity. Let's see what happens if you do. Actually, no, I'm going to go back to that blue. And this might look familiar to some of you that tried this. I'm going to say don't try this. Where's my Y? This at home or, at school, wherever you're taking the AP Calculus exam, which, it's entirely possible it might be at home. So let's say that I take the limit as x goes to pi from the left, sine x was on the top, 1 minus cosine x on the bottom, and I'm not being thorough about this. I'm not checking 0 over 0 business, and I just go, oh, I'm supposed to do L'Hopital's rule, so I do limit as x goes to pi from the left. Cosine is the derivative of sine, and on the bottom the derivative of 1's gone, and then derivative of negative sine is the derivative of negative cosine is negative sine, which is positive sine. And then once again, just doing a direct substitution, you know what I did? I forgot this guy. That is equal to, let's see, cosine of pi is -1, and the sine of pi is 0. Oops, here, let me do this then with a little arrow, because this is going to go to either plus or minus infinity. I take a number, divide it by 0, going to plus or minus infinity. There's the vertical asymptote. That's right there. Right, which is pretty close to what we got here of 0. All of this to show you that, no, man, do not do L'Hopital's rule if you're not allowed to. How do you know when you're allowed to? You're only allowed to use L'Hopital's rule if you have that indeterminate form 0 over 0 or infinity over infinity. You can see very clearly that if you use it when you can't, you're going to get a complete wrong answer.